In our world today, 2.3 billion people lack access to clean, uncontaminated drinking water, resulting in millions of deaths annually. The sad fact is that most of this stems from a lack of awareness, a lack of assistance, and a lack of detection. At the same time, however, 6 billion people in the world have access to a mobile device, representing a unique pathway by which we can try to solve this problem. Our mobile application, Impurivision, works by letting the user take two images, one of an empty cup and another of this cup filled with their household drinking water. What the app then does is it subtracts the two images to arrive at what we call a generated raw difference image. We use thousands of such images to train the neural network at the basis of our app. Before developing these images, we first had to identify substances. We picked 11 major contaminants such as gasoline, arsenic, mercury, and lead, in addition to 4 substance groupings or mixtures to account for the fact that contaminants often exist in groups instead of individually. After identifying these substances in mixtures, we then took 2,835 raw difference images using our mobile application. We then augmented this dataset by introducing variations in brightness and rotation to arrive at a total dataset of 8,505 images.
After augmentation, we cropped and compressed our images to accommodate for the lowest quality smartphone cameras in the world. We then built our own deep learning convolutional neural network. These networks work like the human brain. They learn from input data and make conclusions about new data that is fed. Our input data in this case was the 8,505 images that we developed. We applied this architecture to create two models. The first was a purity classifier, which identified whether your water was safe and unsafe. With that, we achieved a 97.4% accuracy. In the case that the water was deemed to be unsafe, we developed the substance classifier, which would identify substances that might be in your water. We achieved a 89.4% accuracy for that. We've also developed two additional features. The first is the report feature, which lets users report contamination to local authorities. The second is the map feature, which publishes all test results on a publicly accessible map for use by governments and researchers. The Impurivision app carries immense potential to translate robust accuracies into real-world benefits. Most importantly, it eliminates the need for expensive probing technology that is often difficult to distribute by putting the power of detection directly into the hands of people. After refining our algorithms, expanding upon our dataset, and accounting for possible sources of error, we hope to publish our mobile application on app stores for use in the real world.